majority element. Given an array nums of size n, return the majority element. The majority element is an element that appears more than half the times of the length of the nums array. You may assume that the majority element always exists in the array. For example, in this example, array of 3 to 3, 3 appears 2 times, which is more than half the length of the array. Therefore, the majority element in this array is nums. Similarly, in this example, 2, 2, 1, 1, 1, 2, 2, 2 is appearing 4 times, which is more than half the length of the element of the array, and therefore the majority element is 2. So it is guaranteed that there will be always an element that is existing with that particular condition satisfied. Therefore, we are guaranteed to find that element. And also, the element in the array will be ranging from this value to this minus 10 raised to 9 to 10 raised to 9. One easy way of doing is to create a dictionary of this nums array elements with key as an element value and the value as the count of that particular element in the array, and then find which key value has the maximum number value associated with it and return that element. But the problem with that is that it will have O in space and also O in time complexity. So we are looking for a linear time complexity algorithm which uses the least amount of space. Let's see how you can see. The question that they're asking is, could you solve the problem in linear time and O1 space complexity? In the brute force method, if you're using a hash table, we need O n space complexity. Now let's see how we can do it in a linear time space complexity. So what we do is, we will have, suppose I'm taking this example, we will have a number variable which will store the current number variable but has the maximum count in the array, and the current and a count to keep track of the count. So as we go through the array, we see that this with this condition, so nums will hold the first element of the array as of now, which will be 2, and then we will enter the for loop. In the for loop, we will check if the count is 0. If the count is 0, then we will assign, so for the first 2, we are going to assign number is equal to 2 since the count is 0, and also we will also check if the number is equal to the current element in the array. That will be equal to nums, so number equal to 2 and nums of 0 is equal to 2, therefore we will increment the count. Now for the second 2, we will check if the number is equal, if the count is equal to 0, count is not equal to 0, then we will check if the number is equal to the number. Therefore, we will increase the count. Now for 1, we will see if the count is equal to 0, it is not equal to 0. Then we will check if the number 2 is equal to 1, it is not, therefore we will decrement the count. So number is currently 2, and then we will decrement the count to 1. Then for the second one, we will see if the number is, which is 2, is equal to 1, and also the count equal to 0. So count is not equal to 0, therefore we will check if the number is equal to the nums of 5, which is 2 is not equal to 1, therefore we will again decrement the count. Now for the third number, we can see that count is equal to 0, therefore we will assign nums of 5 as number, and then we will go and see number 1 is equal to 1, therefore count is equal to 1. Now for when we encounter this 2, we know that count is not equal to 0, therefore we will see if the number is equal to, so in here the number is equal to 1, therefore we will decrement the count. Now for the next 2, the last 2 in the list, we will see that if count is equal to 0, therefore count is equal to 2. Number is equal to 2, count. Since count is 0, we will assign number as the current element, that is 2. And then count, and since number is equal to the nums of current element, we will keep the count incremented. And then at the end of the array, we will return the number. So the logic behind this algorithm is that the element which has the more or the majority count in the array will sustain the count and will never go to 0. And every other element which has less count in the array will cancel each other out as we go through the array. So when we encounter 2, we will keep a count of 2, and when we encounter 1, we know that 2 possibly cannot be the majority element now that we got a different element other than 2 in the array. So we will decrement the count until all the 1s are encountered. So we will decrement the count of 2 and we'll start counting 1. And when the next 2 occurs, now we know that 1 might not be the majority element. Also, till now we still don't know the count of 2 or the total count of 1. We might encounter 1 again, or we might encounter more 2s again. So we make sure that each time we encounter a new element, we will decrement the previous considered possible majority elements count. If that goes to 0 with this new element, we know that element cannot be the majority element, and this particular element that we have encountered could be a majority element, and then we will start the count again. We will keep the count of this newly encountered element that made the previous elements count 0. So this is the basic idea behind this algorithm. Now let's code it up. So as I said, we need a count to keep track of the count, and a possible majority, we'll call this the possible majority element. So that element equal to, let's say that it is the first element. Now we will go into the loop for every element for I in range of length of nums. If the count is equal to 0, then we can say that the possible majority element is the current element that we are considering. Also, we need to check if the possible element is equal to nums of I, then we will go and increment the count, else we will decrement the count, and then we will at the end return the possible majority element. Cool, and submit. Okay, the time complexity of this algorithm will be of n, because we are at the in any case we are going through the whole array, and space complexity will be of n, because we are not using in any case any extra space, which increases with the increase in the length of the array. Only we are using these two, which will be always constant. So that's it. Thank you.